All right, 2.2 conditional statements. All right, so if we have a bumper sticker here, it says, if you can read this, then you are too close. I apologize for the blurriness of this sticker. The company that prints this bumper sticker accidentally reworded the original statement and printed the sticker 3 different ways. Suppose the original sticker is true. If you can read this, then you are too close. Are the other bumper stickers true or false? So let's take a look here. Let's look at our bumper sticker A. If you are too close, then you can read this. So can we come up with a counterexample that would prove this to be false or true? So if you are too close, then you can read this. Okay? Well, and one thing I like to say is, well, what if I was blind? I could still be close and then I can't read it, right? Or what if I need reading glasses and I can't read when I'm super close? So this would be a false statement. Okay, so let's look at the next part, B. If you cannot read this, then you are not too close. Okay, so for the same reason, if I need reading glasses or if I cannot read this, it's assuming that I'm not too close. Well, I could be too close, so I couldn't read it, so this is false. The last one, if you are not too close, then you cannot read this. Okay, based on our statement, the original statement, if you can read this, then you are too close. So if you are not too close, then you cannot read this. So this is going to be a true statement. Okay, so notice that all these are if-then statements, and that's what we're going to focus on this lesson, is our if-then statements. So this kind of leads us to here, you can describe some mathematical relationships by using a variety of if-then statements. Most of our theorems are going to be if-then statements in our textbook this year. The study of if-then statements and their truth values is the foundation of reasoning. So if this happens, then this happens. Okay, if you do computer programming, you do a lot of if-then statements. If this result, then this result. Or if this number is inputted, then this is the result. Okay, so this is the foundation of reasoning. So let's take a look here at our conditional statements. Okay, conditional means that something has to happen. So a conditional is an if-then statement. If this happens, then this is our result. Okay, now the parts of a conditional statement are the hypothesis and the conclusion. The hypothesis is the P part. Okay, it's the if. The conclusion is the Q. So the if follows the following the word. The P part follows the word if. So if P, then Q. So this is the way it's read here. If P, then Q. Or you can also see it as P implies Q. And if you want a diagram here, this means that P implies Q. So if P, then Q. So if it's a part of P, then it's a part of Q. All right, so that's called a conditional statement. So you're going to hear us refer to conditional statements not only in this chapter, but throughout many chapters. So let's take a look at example 1, identifying the hypothesis and conclusion. So, and many of these answers may vary, okay, just slightly. But let's take a look and see what they are. So, if an animal is a robin, then the animal is a bird. Okay, so first what we're going to do is we're going to identify the hypothesis. Remember, the hypothesis is our if. So we're going to put down here what follows the word if. So here's if, and then we're also looking for the keyword then. So an animal is a robin. So hypothesis, an animal is a robin. The conclusion, the animal is a bird. Okay, so hypothesis is what follows the word if, conclusions follow the word in. So this one over here, if an angle measures 130, then the angle is obtuse. So the hypothesis is our if, so we say an angle measures 130, and then the angle is obtuse. Okay, so if an angle measures 130, then the angle is obtuse. All right, so let's look at writing conditional statements here. How can you write the following statement as a conditional? So we're going to work the first part together, and you guys can write the second part. Now this may vary from word to word. So let's look here. Vertical angles share vertex. Okay, so we're going to make it an if-then. So the first part, we got to start with our if. So if, and two angles make vertical, so if two angles are vertical, then the angles share a vertex. So we got all the information that they gave us in this first statement here, but we've made it a conditional. If two angles are vertical, then they share a vertex. Only way it can happen. Two lines intersect. The vertex they share is where the intersection. So you try part B. Pause the video, see what you get. All right, so dolphins are mammals. If an animal is a dolphin, then it is a mammal. Okay, so that's just one example that you could use. Once again, we have the if and we have the then statement. All right. Truth value. The truth value of a conditional is either true or false. So your values that we have is either one or the other. To show that a conditional is true, show that every other time the hypothesis is true, the conclusion would also be true. A counterexample is how you can determine whether a conditional statement with a true hypothesis is true. To show that the conditional statement is false, you would need to find one counterexample for which the hypothesis is true and the conclusion is false. So the truth value of the condition would be false. So it has to be both true in order for the conditional statement to be true. If one of them is false, then the whole thing's false. Kind of like a positive and negative. If they're both positive, then the answer is positive. If one of them is negative, then the whole thing is negative. All right, so let's look at example 3. If the conditional is true or false, okay, determine whether they are. If it's false, then find her counterexample. So if a woman is Hungarian, then she is from Europe, or she is European. And for those of you who don't know, Hungary is in Europe. So, if the woman is Hungarian, then she is European. That would be true. All right, so now I want you to try and see if you can find if they're true or false. If they're false, give a counterexample. Pause the video, come back and check it when you're done. All right, so let's look. So if you think of a number like 9, 9 is divisible by 3, but it's odd, so that's true. But then we can come up with 12 to be divisible by 3, and 12, and it comes up to be 4. So 12 is even. So this is a counterexample that tells us that it is false. Okay, so this is a false statement. Then if two angles form a linear pair, then they are supplementary. There's no other way to get around that. That is a true statement. All right, negation. If you negate a statement, P, that is the opposite of the statement, the symbol is the squiggly line before the P, or it could be the squiggly line before the Q. So that this means when you see it like this, it's read not P. So this is like a not symbol. So not P, not Q. All right, so let's take a look here at our chart. Okay, now every conditional statement has three related conditional statements. Okay, the first one is called the conditional. That's our original statement. Then we have the converse, the inverse, and the contrapositive. The converse is where we exchange the hypothesis and conclusion. So we take our P and Q and swap them in places. The inverse, it's going to negate both the hypothesis and the conclusion of the conditional. So it's going to negate the conditional. That's called the inverse. And the contrapositive negates both the hypothesis and the conclusion of the converse. So let's look at some examples of this. In the conditional, if the measure of angle A is 15, then the measure of angle A is acute. So angle A is acute. So if it's 15 degrees, it's going to be acute. That's P to Q. If P, then Q. If angle A is acute, then the measure of angle A is 15. Okay? That's if P, or if Q, then P. So we reversed them. So we swapped our conditional statement around. So we swapped our hypothesis and conclusion of a conditional. So this one says you leave them both in the same order as your conditional, but now we're going to negate them. So if the measure of angle A is not 15, then angle A is not acute. Okay, so the way we'd write that would be not P, then not Q. This is how you'd say it in words. If not P, then not Q. And then the contrapositive. If angle A is not acute, then the measure of angle A is not 15. Okay? So what I want you to do is I want you to figure out, in your last column, I want you to write if they're true or false. Is this a true statement? Is the conditional true? Is the converse true? Is the inverse true? Is the contrapositive true? So I want you to write that down. Take a moment, pause the video, write those down, and come back and let's see how you did. Alright, so these are the truth values of the statements we just looked at. Equivalent statements have the same truth value. So if they're the same truth value, we say that those are equivalent statements. So in the first one, if the measure of angle A is 15, the measure of angle A is acute. This is true, okay? Because if it's 15 degrees, we know it's an acute angle. Now the converse says if angle A is acute, then the measure of angle A is 15. So if you can come up with a counterexample, you know it's false. And the counterexample could be, it could be 16, it could be 17 and still be acute. Then if the measure of angle A is not 15, then the measure of angle A is not acute. Well, that's not true. It could be 17, or it could be 18, it could be 24, which is still acute. So that's false. And then if angle A is not acute, then angle A cannot be 15. So if it's not a degree measure from 0 to 90, then it cannot be 15, which is a true statement. So what you want to notice here is the conditional and the contrapositive are both what we call equivalent statements. Converse and inverse are equivalent statements. They're both false, where these are both true. So conditional and its contrapositive are equivalent statements. They're either both true or both false. So if the conditional is true, then you know your contrapositive is false. I mean, it is also true. So let's reverse that. If the conditional is true, then the contrapositive is true. If the converse is false, then the inverse is false. And there could be a case where all of them are true. But the two in the middle should match up, and the two on the outside should match up. The converse and inverse of the statements are also equivalent statements, based on that what we just talked about. So what are the converse, inverse, and the contrapositive of the following conditional? What are the truth values of each? If each statement is false, give a counterexample. If the figure is a square, then the figure is a quadrilateral. So this is our conditional statement. So let's right now decide, is this statement true or false? If the figure is a square, then the figure is a quadrilateral. To help remind you, a quadrilateral is any four-sided object. So does the square have four sides? Yes. Is the quadrilateral? Yes. So this would be true. Okay. So now I want you to write the converse, the inverse, and the contrapositive for this conditional statement, and then I want you to give me the truth values of it. So pause the video, take a few minutes, and fill this out. So let's take a look here. So the converse is where this is our P to Q. So what we're going to do is we're going to reverse this and do Q to P. So we're going to reverse it. So if the figure is a quadrilateral, then it is a square. The inverse is where we're going to negate our conditional. So it's going to be if not P, then not Q. And then the contrapositive is where we're going to take it is not Q, then not P. So we go back to this one here and we're just negate it. So let's look to see, is this true? Okay, if the figure is a square, then we said the figure is a quadrilateral. That's true. If the figure is a quadrilateral, then the figure is a square. Well, it could be a rectangle, so this is going to be false. Could be a kite, a lot of different things. If the figure is not a square, then it's not a quadrilateral. Well, it could be a kite, which is still a quadrilateral. So that's going to be false as well. And remember, these are equivalent statements. So these two right here, the converse and the inverse, are going to match up. So if one's false, they're both false. And so by using that statement before, if this is true, then our last one should be true. So if the figure is not a quadrilateral, then it's not a square. So if it's not a quadrilateral, it means it doesn't have 4 sides. Then it can't be a square. That makes it true. So this is an example of writing truth statements, writing the conditional, writing the converse, inverse, contrapositive, and determining whether things, conditionals, are true or false. All right, so this concludes our second lesson, lesson 2.2, and called the conditional statements.